Okay, this is what I'm testing right now, but I'm making new coils, new stator plate, and so this one, as I've been saying, it has 8 magnets here, 8 magnets here, and they're staggered like I guess 180 degrees off from each other, so this magnet's in between these two magnets on this rotor. The magnet on the other side's right here, so it goes AC, hitting the coil one way, hitting the coil the other way. Okay, so that's one rotor configuration. The other rotor configuration I've been testing is north, 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 all facing same polarity, and then it gets pulsed really quick, 16 times the revolution, and uh, and with this way I can get speed up under load and also no lens under load when I have them all north. When I have north, south, north, south, north, south, north, south, I get more power produced, but I couldn't get the speed up or the no lens with rotors like that. So I'm going with north, north, north. These are 20 millimeter wide magnets, and there's only 15 millimeter in between. So when I was using these coils, when I had weak, very thin magnets here, I could get it to work pretty good, but it wasn't making much power because it wasn't being induced into the coils very far. And so because I got kind of greedy and made very large generator coils, 2/3 of the core, 45 millimeter long, is generator coils, 15 millimeters is the motor coils, sharing the same core. So that's the design of this one. The motor coils, I made them kind of dome shaped with the ferrite tip sticking out a little bit, and so that worked pretty good because you need to have a pinpoint pop, pop, pop right on the edge of the magnet to make it go. But because they're like north and north, if your coil's too big, it'll like push it this way and push it this way, and you're having overlapping fields. If I had north-south, actually with a large coil in the middle, it would push and pull at the same time. But you have to flip the polarity for the next one. But because I could not get speed up or no lens with north-south, north-south magnets, I'm going with north, 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 north magnets with these larger 20 millimeter wide magnets with 15 in the middle. So anyways, when I went, I got some N52s and I made them, popped them on there so it's much stronger field. Now I get this problem of the overlapping fields, which I didn't have before. So I wanted to get more power out of this. So I made some new stators, new stator coils, and a new stator plate, especially for this design of a rotor with all facing the same magnets. So I'll show you that just a minute. Okay, this is the new coils. They're like this. Before, I also, in the motor generator I just showed you, I rimmed around the ferrite with 45 millimeter lengths of florist wire, like 12 of them. So there's kind of a laminated steel rim around the ferrite core. This is what the ferrite core is like inside there. 45 millimeter long. There it is in there. So this one, I don't have the steel laminate. That was probably a mistake. Bill Moeller would always say, do not have steel or iron near neodymiums. So that's, I was hoping for kind of a transformer effect between the motor and the generator coil. That's why I had those steel laminates. So I made new coils specifically that should work well with these, because it's when the fields are not going to overlap so much. It's thinner. The other ones were about like this thick of wines. I was thinking, okay, let's make a lot of power in the generator coil. So I made big thick wines for the generator coils. But what happens is not all the magnets don't get induced by the magnets going by. All the coil does not get induced by the magnets going by. And so all these windings that are not induced by the rotor magnet sweeping by are nothing but resistance. It's like putting a big resistor on the coils. Now there's another thing. If there's a motor coil, this much of it's a motor coil and then this much of it is a generator coil, and that's what I was doing at first with this dual rotor motor generator. And so the generator coils attached right to the back, not attached, connected, but physically they're butt up against each other, and they share the same core. So I've been doing this a long time. Whenever you have a motor coil, extend the core out and then have an induced pickup coil on the back end. So the front of the motor coil is doing work, and the back end, instead of not doing anything, now induces into a pickup wind, I call it. So I had this divided 15 millimeters to 45 millimeters, and then I had the generator coils really big. So that's what's in the one I just showed you. And it was working good as long as I have very thin, like 2 millimeter, 1.5 millimeter thick magnets, so there's not such a strong field. And all the action happens on the edges of the magnets. So I could get it up to 2000 and got speed up and got no lens. But I wasn't making much power because the magnets are so thin. I've mentioned this before. So I went with thicker magnets, N52s. And now I have the problem of overlapping fields where it pushes this way and pushes this way. So I mentioned that before too. So these should be good for this type of rotor now. And what I've done is, instead of doing the motor coil and the generator coil, I'm spinning it with a rotoverter, either at 1800 or 3600 RPM to test. So I wanted to see this as just a generator coil, not doing the motor coil and the generator coil thing. So this is just all one coil here in these new coils I made that are in here now in this new stator plate. So this one, I can just take the old stator plate out and put this one in. And now one way I was going to go was keep the generator coils as generator coils and then use the run cap phase, step it down, and pound the motor coils with the run cap phase. And I did some experiments with that with the other one. And this one, what I'm doing is I have 8 wires multi-filer that I wound, 25 gauge wire, and then I split them into sets of 4 in series, and now I have them bifilar. So if I want to, I can still have half the generator coil be generator coil, and then I can pound the other bifilar with the run cap phase if I choose to. So there's 4 wires coming out. Whoops. 4 wires coming out of each coil now. And there's an in and out of one bifilar, and then in and out of the other. I call them multi-filar bifilars, I guess. So I need to solder all these up. I'm going to run them all in series. And it'll be 2 separate circuits for half of the multi-filar bifilars and then another one. So I can either connect them in series to get highest impedance, or I can connect them in parallel to get lower impedance, more current out of it, or I can use 1/2 as a motor coil and 1/2 as a generator coil. And but I've been spinning this with a rotoverter, so this is what it is. So I got these all exactly the same height sticking out, and also the ferrite core is like, you know, 1.5 millimeters or so sticking out, so it'll be real accurate, exactly the same. So when I spin a rotor, I can get really good air gap. So this stator is going to go in the fat generator coils, the existing one that I just showed you outside. And the rotors are going to be either these, and I'm also going to test these with where I have 8 magnets this side, 8 magnets this way, 180 degrees off, so it makes AC pumping this way and pumping this way into the coils. So sorry if this is boring, but I am kind of documenting what I'm doing, if anybody's wondering. So what else I got is I made a couple rotors out of polycarbonate. These are going to be like the motor rotors, and I'm sticking these 3/8 inch by 1/2 inch neodymiums, 16 of them here. And so now I don't have this 20 millimeter wide thin magnets, but 15 millimeter, and I'm going to use these as the rotor magnets. And I made 2 of these rotors. And just a minute, I have this generator rotor. I'll show you in a second.